To predict precipitation, basically what you want to be doing is looking at the cation and anions that are present in solution and just work out if any of them have an insoluble product. If there's an insoluble product, then that is going to come out as a solid, and the fancy word for that is precipitate. So it's really important when you see the names written down like this that you know what ions are involved. So potassium hydroxide, for example, is coming from potassium plus and the hydroxide ion OH minus, so it's going to be KOH. Okay, iron 2 sulfate is iron 2 plus, and the sulfate ion SO4 2 minus. So the way I like to do this is just put the cations down one side, so potassium and iron 2 plus, and the anions on the other side. So in this case, we have hydroxide and we have the sulfate ion, and do what we call a solubility table. Now, if you have solution A that contains potassium hydroxide, I think you can take it as golden that potassium hydroxide is soluble. Same as if you have iron 2 sulfate, sulfate. Is it a solution? It's soluble. So actually all you've got to do is look at iron 2 hydroxide and potassium sulfate to see if either of them are soluble or not. So refer to the solubility table. So we're going to look at hydroxide first. Hydroxides are always insoluble unless the metal is lithium, sodium, potassium, rubidium, cesium, ammonium, calcium, strontium, barium. Iron 2 is none of these, so that will be insoluble. So that will form a precipitate, okay? So if we want to check our sulfate real quick, sulfate's always soluble. The only exceptions are barium, strontium, mercury, lead 2. Potassium's none of those, so potassium sulfate is going to be soluble, okay? So then we've got to work out what the formula of this compound is going to be. Well, it's iron 2 and hydroxide 1 minus, so it's going to be FeOH subscript 2, and that will form a solid, right? So that would be a precipitate. So if I'm going to fill this in on my ALEKS table right here, I'm going to say, yes, a precipitate forms, and the empirical formula is FeOH subscript 2. Okay, copper 2 chloride and ammonium sulfide. So again, we got copper 2 is one of our metals. Ammonium NH4 plus is our other cation. Okay, and then what are we mixing those guys with? Copper 2 chloride, so Cl minus, and sulfide S superscript 2 minus. So at this point, it's really so important to know how ionic compounds are formed and what your standard ions are and stuff. So copper 2 chloride must be soluble because it's in the question. Ammonium sulfide must be soluble because it's a solution in the question. You can check if you want to get more practice, but I'm trying to show you an efficient way to look at this. So we're looking at ammonium chloride. So look at your table. Chlorides are always soluble. The only exceptions are blah, 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 blah. Ammonium is always soluble in water. So it's a pretty dead cert that ammonium chloride is going to be soluble. Okay, what about sulfides? Well, let's take a look. Sulfides are usually insoluble. Exceptions: group 1 metals, ammonium, calcium, strontium, barium. I guess that's why ammonium sulfide right here was in the solution, right? It was soluble. But now we're looking at copper 2 sulfide. That is not one of those exceptions, so it must be insoluble, which means it's going to form a precipitate. What will be the formula of that precipitate? I cannot write today to save my life. Well, copper 2 plus and sulfide is just going to be CuS, right? It should balance out like so. Okay, so does a precipitate form? Yes. And too many ticks. It's going to be CuS, copper 2 sulfide. All right, so then the last thing we're asked about is cadmium nitrate and manganese 2 chloride. So cadmium, Cd2 plus, and manganese 2, Mn2 plus. And then what are our ions? Anions, I should say, nitrate and chloride. So let's look at cadmium nitrate. We know that's soluble. It's in the question. Manganese 2 chloride. We know that's soluble. It's in the question. Look at our solubility table. So what about cadmium chloride? Chloride's always soluble. Silver, mercury, lead, exceptions. So none of those exceptions apply. So cadmium chloride I would expect to be soluble. Manganese 2 nitrate. So let's have a look what it says about that. Nitrates, always soluble, no exceptions. That must also be soluble. Therefore, If I mix cadmium nitrate and magnesium 2 chloride together, I start out with a solution of cadmium 2 plus, nitrate NO3 minus, manganese 2 plus, and chloride Cl minus. And when I mix them together, I still have a mixture of cadmium 2 plus, the nitrate ion, manganese 2 plus, and the chloride ion. So there's been no net change. So when there is no precipitation reaction, basically you start with a mixture of ions and you end up with a mixture of the same ions. So there is no net chemical change. And that is all that's happening.